They will go also for chapter number 3. We'll talk about 3.2. In 3.2, today we'll talk about something called Neville method. In the previous week, we talked about Lagrange method to find approximation for values. And this week, we'll go to another thing called Neville method. Let's make revision for previous week and talk about this one. Okay, where's the pen? This is the pen. Where is this? For Lagrange, we said that means I want to find Px. So Px was an xn positive an minus 1 xn minus 1 plus a1 plus a0. We said this is, for example, if I want to find degree number 2, I need to find 2 points. For degree number 3, I need 4 points. For degree number 2, I need 2 points, and so on. Okay. And we said that means Px, we can write as Lx, 0x, for example, f0x plus L1x, f1x, and so on. And we defined L0 and L1 in the previous week, and F0, F1 in the previous week. Okay, this is repeated. Where is the problem? For example, if I ask you find B3. So for if I want to find value, here I want to find formula. See? So if I need formula, I need Lagrange. For formula, I need Lagrange. Good. For value, you have to find, first of all, formula, then find value. And again, for example, this is B3. So you have to calculate this one and this one. And for formula, for example, we have sometimes degree number 1, degree number 2, degree number 2. So you have to find 3 formulas, 1, 2, 3. This is for degree number 1, this is for degree number 2, this is for degree number 2. So we have 3 values. For this is for degree number 1, this is for degree number 2, for this degree number 3. And this is not easy way. So summarization for this one. If I want to find formula Lagrange, if I want to find a value directly, first way and first method was Lagrange, but Lagrange based on the degree 1, 2, 3, and so on. Now we have a question arise to our brains. Can we find values directly without formula? John, what you are saying? Yes. Can we find a value without formula? Yeah, sure. Sure, we can find. And this is our job today. Our job today is to find a value without finding formula. How we can do this? Okay. So this is our job, and today we have this one, Neville method. Neville method is a way, is a practically difficult with Lagrange, is that error is difficult to apply. So in Neville method, we want to find or do something like this one. In Neville method, we want to apply and find formula, find value without formula. Okay, let's cut this one. And what's B0, B1, B2, B3? We don't know information about this one. Give me a little bit time. We'll talk about this one in details. So what are those? Those are formula. For example, see the Neville. This Neville, we have 2 columns. First of all, we have to make table like this table. Here, how many values for x and y? 1, 2, 3, 4, 5 values. So for 5 values, we have degree 4, 3, 2, 1. So we have how many degrees, Amin? We have 4 degrees. For Lagrange, we need more time. You have to calculate Lagrange for degree number 4, for degree number 3, for degree number 2. It's so long. But here we can find directly. How we can do this? Okay, let's start with this one. X0 is clear. B0 is Y0, Y1, Y2, Y3, Y4, and also those are given. Those are given. Now, as I said before, here we have 5 values. So we have 4 degrees. Where are these degrees? See, Amin, see, Arda, everyone. This is degree 1. This is degree 2, degree 3, degree 4. So can I find directly the results? Yes. For all degrees, yes. Good. Here is the Neville method. In Neville method, we are focused on values, not formula. Repeat. In Neville method, we are focusing about values, not formula. So, for example, here I have 5 points. So I have 4 degrees. If I have n point, I have n minus 1 degree. So I can find degree number 1, 2, 3, 4. Is it clear until now? Any question? Okay. Now, what are those for jump B01, B01? Okay. See, from this point and this point, I can get this. From this and this, I can get this. From this and this, I can get this. From this and this, I can get this. Now, for degree 2, this and this, I can see it. And see, I have 1 and 1, so it's common. So we can see B0, 1, 2. This and this gives to me this. I have here 2 and 2. So B1, 2, 3. This and this gives to me B2, 3, 4. On the same thing, B0, 1, 1, 2. See 1, 2 with 1, 2. So here gives to me B0, 1, 2, 3. Another one, 2, 3 with 2, 3. So gives to me B1, 2, 3, 4. Last one is this. I have 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. So those 2 values give to me B0, 1, 2, 3, 4. Is it clear? Okay. Now, Hujam, what is B01? What is I will tell you. But is this one clear? Any question for this? We'll solve example. Just wait a minute. I'm talking about our concept. Now, in your book, take photo for this. It's very important. Take photo for this. It's very important. Okay, yeah, finish. In your book, we have table 3, 4. They changed it to another symbol. Excuse me, use this. This is the easiest one. In exam, you are responsible for table 3.3. 3.4 are rejected or is rejected. So in exam, you are responsible for 3.3. This one, I will draw here. This one is rejected. I know it's correct, but for exam, is rejected. you must use the previous one. Now, what are those values? Okay. See here, for example, this table. I have 1, 2, 3, 4, 5 values. This is x and y and x. So this is x and y. And here I want to find the values. So this is x0, x1, x2, x3, x4, and this is b0, b1, b2, b3, b4. So this, I guess it's clear. Now we changed y to bz, b. So here I have b0, b1, b2, b3. Okay. Now how we can find the values for those points? Let's check. Okay, first of all, I will calculate B01. I write the formulas for those. Okay, here. So how can I write B01? Okay, let's open this here. I will take this. Copy. Put here. Now, we want to find B01. B01 it is. First of all, here we have something. I want to find, which I know x0, I know x1, I know x2, I know x3, I know x4. So you have something called x minus x minus. What is this x? If I return back to your book a little bit, excuse me for this, and let's read the question. Let x0 is this, x1 is this, x2 is this, x3 is this. Good, 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 good. Where is x? Where is this? See here. In this question, these are 5 polynomials of degree 0 constant. The approximate, I want to find 1.5. This question, he asked me find values for f 1.5. So this is x. Or I can use the x question mark. In our formula, I cannot use x. Clear? Okay. Let's take this example also with me and put on the same thing. Okay, this one. And let's try to solve both together. Here. So now we have example and the formula. He asked me find x1 1.5 and it's a question mark. So where is this? See here. X equal 1.5. So this x0, yeah, right? x0, x1, x2, x3. So between x1 and x2. Between x1 and x2. Okay, now, if he asked me about degrees, you read something. This is degree 0, degree 1, degree 2, degree 3, and this is degree 4. This is what you can see here, degrees. Okay, if he asks me, focus with me, everyone. If he asks me find degree number 1, which value? My value between x1 and x2. So if I want to ask me, where is 1, 2? Here. So this is one value. Is to clear this or repeat? Is to clear or repeat? If I want to find this value, so if I ask me about, for example, degree number 2, where is 1, 2? Where is 1, 2 here? So I can find this or this for degree 2. For degree 3, I have to find this or this. For degree 4, I want to find this one. So based on the degree, and where is my x value? The variable x is used, this one, or x question mark if it's correct. So for degree 1, I need 1, 2 between 1 and 2. So this one. For degree 2, B0, 1, 2, or 1, 2, 3. For degree number 3, I have B0, 1, 2, 3, 1, 2, 3, 4, and this is for degree number 4. Okay, now let's talk about values. For degree 1, B01 is, in practice, minus x minus x0, x minus x. This is x. X here is 1.5 in this example. Multiply B0, P1. Here we have, see, we flipped. Sorry, here, sorry. B1, B0. I did mistake. Then in the denominator, you have to change. X1 minus X0. Is it clear? Now, for another one, P1, 2, it is x minus, practice, minus x minus x1, x minus x2. Here we have, okay, let's change x2 minus x1. And here we have, flip it, B2, P1. Is it correct? It's easy. Now, for third one, P2, 3. It is, again, practice, minus x minus x2, x minus x3 minus x2, and here we have B3, B2. Continue. For degree 1. Okay. B, I will write for degree number 2. Now, like this one. B0, 1, 2. It is open brackets, x minus. First value is x0. Last value it's x2 over x2 minus x0. Good. Now, what are those values? See, B02 it came from this and this. So this is another value, P12, and this is the first value, B01. Can you repeat? Can you repeat? Now, another value, let's clear this. See, same thing. Here, and I will write for B123. 1, 2, 3. So it is x first, it is x1, x3, x3, x1, and here we have x1, 3, 1, 2, 3 came from 1, 2, and 2, 3. So it's last one, first one. Is it clear? Easy? Okay. Now, continue. For same thing, for degree 3. Now, for degree 3, if he asks me about degree, that means this value or this value. So it is for B 0, 1, 2, 3. So first value is 0. So x minus x0. Last value is 3, so x minus x3 over x3 minus x0. Now, B0, 1, 2 came from here. The second value, it's P1, 2, 3. Here it is about B0, 1, 2. Is it clear? Now, same thing for degree, this is degree 3. Now, for degree 4, same thing. Okay. B, degree 4 is B 0, 1, 2, 3, degree 4. So first value is x0, second value is x3, x3 minus x0, and this is came from this and this, so it's p 1, 2, 3, 4. Here it is b0, 1, 2, 3. Is it hard or easy? If you know the formula, it's easy for after that. If you know the formulas, how you can write the formulas, it's easy after that. Okay, now let's return back to our question. In our question, he asked me find value for x equal 1.5. Where is x.5? Here. Here. So for degree 1, 2, 3, 4. For degree 1, this is the value. Where is 1, 2? This 1, 2. For degree 2, this or this, you can find this or this. For degree 3, this or this. Where is 1, 2? 1, 2 here. For degree 4, it's this one. Which one is more accuracy? Absolutely 4, then 3, then 2, then 1. Any question about this? Okay, now let's return to your book. And see, I want to show you for just a minute. For example, Q1, it's B1, it's B01. See the value, 0, 5, 3, 2. If I finish the table, this is the table. For example, he asked me where is the value for B for this value. Which one? It is about 1.5. So where is 1.5? This is 1.5. It's what? For degree number 1 and degree number 2, degree number 3, degree number 4. And to find the result for each one of them. Okay. See here, for example, for first value that I talked about it, see this one is this x0, x1, 2, 3, 4. And this is my value is here. Here in this one, it's x variable. So B01, B0, B1, B2, B3, B4, B01, B12, B23, B34, B012, B123, B234, and this will continue. So if I want, for example, for B12, this is the value. For second one, this or this, so see the values. For another one, this is the value. And this is the fourth one. So let's read the values for each one. See here, 0.5102, this degree 1, degree 2, 0, 5, 1, 2, 4, 5, 7. So a little bit same. This is for degree number 3 and degree number 4. Absolutely, this is more accuracy, or the most accuracy one is this one, degree number 4. Any question for this? So in exam, excuse me, read the question carefully. Which degree he asked me? Maybe he asked me find all table. Maybe he asked me find degree number 1, degree number 2, degree number 3, degree number 4. So you have to know the degree. Okay. This is now. It's after that we don't need after that. This is the last thing. And let's go to the example here in your book. Use Neville method to obtain approximation for Lagrange interpolating polynomial of degree 1, 2, 3. So as I told you before, here we have degree number 1, we have degree number 2, we have degree number 3. So you can calculate for degree number 1 and degree number 2, degree number 3. So you have to make table and you can find degree number 1, 2, 3, 4. And where is x? X is this x. This is x, 8.4. You have to fill the table and find the value. In Lagrange, you have to find formulas. Here you have, it's easy to find table and you can do and apply by Excel. You can apply by Excel. I will show you the one of my Neville method that I did by myself. Where is it? Here. I guess this one. Just a minute. I guess I found before. Okay, just trying to check what is it. I didn't find now, but this is Neville example. See, it's easy. For example, find this value. So this is x, this is y, and you can fill from this formula. Find B. This is B0, 1, 2, 3, 4. Find, and you can find the formula here. Create from, and this is the x. You can do like this one. I can calculate error easily. So this is one way to find values based on Neville method. You can do it by Excel also if you want. So return back to our book, and here, for example, use Neville method to approximate root of 3. So this is my x with the following function as values he gives to me, x, and this is fx. So this x and this is fx. You can find y, b0, b1, b2, b3, 4. And same here. Where is my x? This is x. This is x. And after that, you can find the values. You can find the values and compare the result. Compare the result how? I know the root of 3. So I can compare between exact value and approximate value for this one. So this one example also came in mid-term in the final exam. Excuse me, try to solve this one by yourself. Another way or another example is this example. Let's check together. This question came many times. What is this question? Neville method is used to approximate F04. Given the following. Okay. He asked me to determine B05. Where is B05? This is X. B05, this is determine B02. I want to find this. This is my question mark. So in this way, you can, I have start from backward to forward. Here you have this. So from this and this, you can find this. And from this, you can find this. From this and this, you can find this. So this is very important. And this one also is very important in exam. Okay. Here you have to start from back to forward. Question number 7 also came many times, and 8. So excuse me, try to solve it normal way, and you know, something can say it's not abnormal way. Here we have, for example, we have 7 and 8. What's the question say? Question says support xj equal j. Yeah, that's mean xj equal j, x1 equal 1, x2 equal 2, x3 equal 3, and so on. For j0, 1, 2, 3, and it's known that we have b02, b01, and this is my value. This is x. I have p1, 2, 3. It is 3 for 2.5. So here p02 for 2.5. It is 2.5 plus 1. It's 3.5. I'm solving. Last question here. B01 for 2.5, it is 2 multiply 2.5 plus 1, so it is 6. So you can fill the table and find the values.